Alright guys, our next factoring technique is called a sum of cubes. So over here, okay, which is actually very similar to difference of cubes, which I wrote difference of cubes below it so we can kind of compare the two. Okay, so a sum of cubes, first of all, what this says is you must have two terms like before. So far, the ones with two terms are a difference of squares, a difference of cubes, and now a sum of cubes. So if you see two terms and you're trying to factor, it could be one of these three options. Now, sum of cubes is kind of unique because we have a plus sign. A difference of squares and a difference of cubes both contain a minus sign. So you kind of have to know the difference between when to use a difference of cubes versus a difference of squares. Okay, so in order to use a sum of cubes, first of all, you have to have two terms. Secondly, each of these have to be a perfect cube. And if you see that, you will use this formula over here, okay, which is very similar to the difference of cubes. So I'm going to kind of help you guys out and kind of show you some ways you can kind of remember this. Okay, so with the sum of cubes, you start with the plus sign. So you start with what it is, a sum. You start with the sum. Okay, the difference of cubes was a difference, so we started with the difference. And then these two signs, you guys, are always opposite. Okay, if you see here, see how it goes from a plus to a minus here and a minus to a plus here? That will always happen. All right, and if you also notice, the last two terms have plus signs. That will always be the case. Okay, so you start with what it is. If it's a sum, it remains a sum. If it's a difference, it remains the difference. The next sign, you flip it from the first one, and then always keep the last sign as a positive or a plus sign. So that might help you when you're trying to remember the formula. If not, okay, I tried to help, and you might need to find a different way if that didn't make sense. Okay, because you will not get these on your final exam or on my test, so we need to know these formulas. All right, so sum of cubes is pretty much the same thing as a difference of cubes. We just have different signs in our formula. So if you want to go ahead and try this one on your own, you can, because it's pretty much the same as a difference of cubes. All right, so the first thing we look for, okay, I see two terms. So remember, we must have two terms if we're going to use a sum of cubes. And I have to make sure I can cube root each of these. But before we do that, we always must pull out our GCF first. So let's see if there is a GCF. I'm going to look at my numbers first. So let's see, does something go into 16 and 2? Holy hot dog, 2 goes into both. So my GCF will be a 2. All right, and I don't see any other variables that are in common between each of these terms. Okay, so it's just going to be 2. So I'm going to divide each of these by 2. Okay, so 16 divided by 2 will be 8 g cubed. And 2 divided by 2 cancels out and turns to 1, so it'll be 1 h to the third, which is the same as h to the third. Okay? All right, now, be careful. Don't forget, at the very end, you have to put your GCF in the answer. You have to. Okay, so I'm going to go ahead and set up my answer over here. And I'm going to go ahead and put the 2 in front so Miss Long isn't a dum-dum like up here and forgets to write the GCF. I left off my x squared and was silly, so I had to write it in at the end of the example, if you remember. Okay, so I'm going to go ahead and put it here so I don't forget about it. Our bestie GCF always gets forgotten. We cannot forget our best friend, the GCF. Okay, so after we do the GCF, you guys, now we are looking in here to see if we can do a difference of cubes. Okay, so let's see if we can cube root each term. So my A term, I'm going to cube root the first term, which is 8g cubed. And for my C term, I'm going to cube root the second term, which is an h to the third. All right, let's do it one piece at a time. The cube root of 8 is 2 because 2 times 2 is 4 times 2 is 8. So 2 3 times will give me 8. And remember, if you have a variable with an exponent, you divide the exponents by the index. So 3 divided by 3 is 1. So this is g to the first, or just g. All right, I'm going to cube root h to the third. So 3 divided by 3 will give me an h to the first, which is the same as an h. All right, guys, let's set up our formula. Okay, so the first thing I'm going to do is I'm going to put my A plus my C. So I'm going to add the A to the C. So 2G plus H. All right, then it says we square the A term. So I'm going to put this bad boy in a parenthesis with a square. Okay, minus my A times my C, so my 2G times my H. And then it's going to be plus C squared. So I'm just following this formula right here. So plus my C term squared, which is H squared. Okay, let's see what happens, you guys. So I'm going to bring down my bestie GCF so I don't forget about it. Got my 2G and my H. Nothing needs to simplify. All right, remember we have something outside the parenthesis with an exponent. Raise each of these to it. So this is like 2 squared times G squared. So 2 squared is going to be 4, and G squared is G squared. Okay, so that will be 4G squared. Okay, minus 2G times H. 2G times H is 2GH. So minus 2GH. And then my H squared is H squared. Okay, which if you want to put this in a parenthesis, because technically the term was an H and we are squaring it. So H squared is H squared. Don't overthink it. Alright guys, and that's it. That would be my final answer. And yay, I didn't forget about my best friend GCF. Don't forget about him, you guys. He's always left off, and he's our bestie. So don't forget about him.